Density is an important physical property. This presentation will show you how to measure the density of various materials of different shapes. Density is a measure of the compactness of a substance. The closer the atoms or molecules of a substance are, the more dense the substance will be. Density d is defined as the mass m of a substance per unit volume V, or mathematically by the equation, d equals m divided by V. Density is usually expressed as grams per cubic centimeter or g divided by cm cubed. Density is a characteristic property of a material, and is constant at constant temperature and pressure.
How do we determine the density of regularly shaped objects? First, measure the dimensions of the object in centimeters. Next, calculate the volume in cubic centimeters for the shape of your object. For a block, multiply the length by the width by the height in centimeters to determine the volume in cubic centimeters. Measure the radius of a sphere in centimeters or divide its diameter by 2 to obtain the radius. Multiply the radius by itself twice to give the radius cubed, then use the equation V equals 4 divided by 3 times pi times r cubed to obtain the volume. 4 divided by 3 is equal to 1.33 and pi is equal to 3.1415. For a cylinder, measure the height and the radius of the cylinder in centimeters. Then use the equation V equals the height times the square of the radius multiplied by pi to calculate the volume. Now measure the mass of the object in grams using a triple beam balance. Finally, calculate the density d of the object by dividing the mass m in grams by the volume V in cubic centimeters.
To measure the density of a small irregularly shaped object that sinks, we use the water displacement method. Remember that 1 milliliter on a graduated cylinder is equal to 1 cubic centimeter. Add water to a large graduated cylinder to about the halfway mark and record the volume as Vi. Drop a small oddly shaped steel ball into the cylinder and observe that the ball sinks and the water rises. Record the new volume reading on the graduated cylinder as Vf. The displaced volume of water is equal to the volume of the object V, which equals Vf minus Vi. Measure the mass, m, of the object in grams using the triple beam balance. Calculate the density, d, of the object by dividing the mass, m, in grams by the volume, V, in cubic centimeters.
For small, irregularly shaped objects that float, we use a similar method as for objects that sink with one important difference. The object must be held under water, completely submerged, to determine the volume. Add water to a large graduated cylinder to about the halfway mark, and record the volume as Vi. Drop the object that floats into the cylinder, and observe that the water rises slightly. Push the object into the water with a thin wooden stick until it is completely submerged. The water level will rise to its maximum point. Record the new volume reading on the graduated cylinder as Vf. Subtract Vi from Vf to give the displaced volume of water, V. V is equal to the volume of the object. The displaced volume of water is equal to the volume of the object V, which equals Vf minus Vi. Measure the mass, m, of the object in grams using the triple beam balance. Calculate the density, d, of the object by dividing the mass, m, in grams by the volume, V, in cubic centimeters.
The volume of a large, irregularly shaped object is obtained by a similar water displacement method. An object such as a large, oddly shaped natural quartz crystal is a good example. Add a measured amount of water in milliliters to a large glass container. The amount must be enough to completely cover the object when it is submerged. Record the initial volume of water as VI. Drop the object into the water and observe that it sinks while the water rises. Place a mark on the container at the point where the water rose to its highest point. Pour all the water out from the container and remove the object. Add a measured amount of water from a graduated cylinder to the container until the level reaches the mark on the container. Record the measured amount of water added as the final volume, VF. Convert milliliters to cubic centimeters, then subtract the initial volume, VI, from the final volume, VF, to calculate the volume of displaced water, V, in cubic centimeters. The volume of displaced water is equal to the volume of the object. Measure the mass, m, of the object in grams using the triple beam balance. Calculate the density, d, of the object by dividing the mass, m, in grams by the volume, v, in cubic centimeters.
This presentation was produced as a public service to help middle school and high school science teachers develop experiments and demonstrations that can be used in their classrooms. More science experiments and demonstrations are available on the Tops of Santa Clara Valley website, www.topsofscv.org. TOPS, or Teaching Opportunities for Partners in Science, is a program aimed at stimulating greater interest in science by middle school students.